Hi, Carsten, back again. So what are
Hi.
we going to do in this video?
Yeah, in this video, we do a performance test with one virtual machine on one of the created volumes. Why do I do that? Or why should you do that? I I've done a lot of installations, and I have basically three tests I do at every installation. We
Mhm,
did already our live migration test to hammer the network with a lot of data, and now we do a single VM test, and then we do a multiple VM test later called VM Fleet. But you see often things in this single VM test that you don't see in the multi VM test. Yeah, this is
mhm,
really to see the behavior of the cluster. And there is some expectation. So I do always the same test, but we will come to that. So first, let's talk about the virtual machine. And
mhm,
because of the time, I assume everybody of you knows how to install a Windows server in a virtual machine. If not, there are some great videos about that.
mhm,
And we will do an additional video where we do the same test in a Linux machine so
mhm.
that you can compare Linux and Windows. It should be the same. We
So
do
you
this
created,
additional, yeah,
yeah, so you created a Windows box, Windows Server 22,
yeah.
and let's have a look at
Yeah,
what we.
I usually I go to the eval download of Windows Server 2022,
Right.
install a standard version with GUI. I love the
Mhm.
GUI, you know, so it's much easier. I'm old, so I need a GUI, and I have to move my mouse. So I installed it. I gave the machine 4 GB of memory
Mhm.
and 8 virtual processors. So
Okay.
that should be enough. And I enabled, whoops, this was wrong. We are on the failover cluster manager. We have to go to connect.
Mhm,
I enabled the enhanced session mode. So
mhm.
we get a question about the resolution,
Right.
and we have to log in always because we now use RDP,
Mhm.
and I have
And
to
I
type
think
the
you showed it earlier. I mean, that gives you some options like copy and paste,
exactly, exactly.
and changing the screen size, right?
Yeah.
Okay, so now you are within the virtual machine,
Yeah,
and
no name. We've
right.
just enabled a network card. It gets a
Hmm.
DHCP address. I want to download something. I didn't care about the timing. This is
Okay.
only the virtual machine is only a
Yeah.
vehicle. We don't AD join it. We just need it to run
Hmm.
our benchmark test.
Okay.
So, and the benchmark test I use, I know there are a lot of great benchmarking tools out there, and I
Hmm.
love disk SPD, so disk
Hmm.
speed.
Yeah.
But I go to a very old one called IOmeter. And
Hmm.
IOmeter is from last century, last millennium. It's from 1996, sorry, was created by Intel. And I use this one not because it's also old like I am. I use it because it has some unique
Visuals. Mm.
features. Yeah.
Mm.
So we go to iometer.org. Yeah? This is the original site, and you see it. It has a really old layout. And people who do internet for a while know that this was a layout in the 90s for download things. And I download the compiled
Mhm,
x86 and 64 version. There
mhm.
also is the source code and so on, but I download this, and it goes to SourceForge, of course, and we will get it downloaded, and it's a very small download, some megabytes. So you see here, 3.5 megabytes. It's a zip file.
Mhm.
Yeah, I show in folder. I do something I usually do. If I download something from the web, it's marked as unsafe, and I unblock it because I have downloaded this zip file thousands of times.
Yep.
I do the same test in every installation for over 10 years now, and
Mhm.
there was a time where you didn't do storage spaces direct. There were storage spaces and even virtual machines on SAN storage or on single host. So now I have this stuff, and I extract it to
Yep.
just the C drive.
Okay.
Yeah. Now we have under C, we have a directory IOmeter.
Mhm.
I don't bother with renaming it and something. I just extract it there, and we
Yep.
find two two binaries in there. A GUI part, that's the IOmeter, and the worker, that's the dynamo. It's a
Mhm.
two-part file. So this VM I created has also a 50 gigabyte C drive.
Mhm.
Because if you use benchmark tools, they usually hit a test file or multiple test files.
Mhm.
And I like to have a test file of 10 gigabyte, and we will see how we create that. So you see, it's really Intel open source, copyright 2001, and
Mhm.
you find even a mention of 90 and 96. So I agree.
Mhm.
And you see, that we don't get you distracted, I will close everything here. We have just this nice benchmarking tool.
Okay.
So here you see the host name. Yeah, we have
Yes, though.
different
Mhm.
tabs here where we have to do something, and you see these nice icons from a while ago. Yeah, so here we see our host name.
Mhm.
We didn't rename it, and we have a worker for every core.
Core.
So
Mm.
we have 6 virtual CPUs cores. So
8.
it creates, oh, sorry, you're right, 8 cores.
Yeah.
It creates 8 workers.
Mhm.
So now we have to tell where should the test be done on which drive. So and unfortunately the GUI is not complete consistent. So I'm on
Mm.
the host, and if I check the C drive here,
Mhm.
the first worker is set to C, but the second not, and the third
Okay.
also not. So you have to check for every worker it should
Mm.
uh, where its test file is, and that's the inconsistency part of this GUI.
Mhm.
So
Okay.
for every other thing
Setting.
I
Mm.
setting, yeah, I can choose the server name or the computer name, and it will
Mhm.
set every worker, but only for the drive selection we
Okay.
have to do. So I told you I want to do a 10 gigabyte file, and
Mhm.
unfortunately here is not kilobytes, gigabytes, megabytes, or bytes. It's sectors. So you have to know how big a sector was in 2001. And to do it short, it's a 512 byte sector,
Mm.
512 bytes. So two sectors would be a kilobyte.
Mhm.
2048 sectors. I only go with even numbers. We skip the 48 part. So the 2000 sectors is roughly a megabyte. Yeah, no, it is a megabyte.
Mhm.
Roughly, and adding 3 more, it's 2 million is a gigabyte, and we want 10 gigabytes, so we add another zero. So 20
Okay.
million sectors is
Mhm.
a 10 gigabyte file. And
Mhm.
imagine how much data that is. And our operating systems, I downloaded an Ubuntu for our another video. It has 8.4 gigabytes of sheer greatness. And even Windows Server has 5 point something gigabytes. So our installation images are as large as this.
Mhm.
So what do I do then? I start with one outstanding IO. We will talk about that, and
Mhm.
we will tweak that a bit later. But first, I want a baseline,
Mhm.
and I create a pattern file that is full random.
Mhm.
So he will tell us how he does create the full random file. He will create 16 megabyte buffer with sheer random data, and then he will point into it and take another 512 byte and write it to the disk. So that's done. So
Mhm.
I now I know I tell the system how large the test file would be, how many outstanding IOs, that it's full random, and now we have to specify the how what we want to test.
Mhm.
And I decided ages ago to not do a 4 kilobyte test. Why not? Because every storage system is kind of optimized for 4 kilobytes. Our NVMEs maybe have 4 kilobyte sectors, not 512, 4 kilobytes. ReFS, our or NTFS, it's the C drive is formatted with NTFS. It has 4 kilobyte blocks. ReFS part of the cluster shared volume has 4 kilobyte. So 4 kilobyte is kind of ideal. So I wanted to do something that is not ideal, and I decided ages ago to go with 8 kilobytes. Unfortunately, we don't have a predefined test here with 8 kilobytes. So I choose a 4 kilobyte aligned 50% read, and we can look here, 4 kilobyte, 50% read, 50% write, and 100% random. So that's a very heavy test, but I don't want that. I want an 8 kilobyte. So I do edit copy. And the important part is aligned. If you choose aligned, that's important. So the blocks are aligned to the underlying storage system. If you do this one, it's not as fast as the aligned one. So I
Mm.
choose the aligned one. And then I do edit copy and I change this to 8K, get this, rid of the edit one here, and then I
Mhm.
increase it to 8 kilobyte. And this is important. You have to increase it to 8 kilobyte. Otherwise, it would be a marketing test. It's stated 8 kilobyte, but would do 4 kilobyte, right?
Yeah.
So we're not doing marketing here. So now, where is it? We don't have it here, but we have to go down to the end. And here is our test. And I can add it to every worker. Yeah.
Mhm.
So we now every worker has the same test.
Mhm.
And now I can go to the result display. And this is also weird. I choose IOmeter, a very old tool, because I want to see immediately what the tool is doing, not doing a test for 3 minutes and then get a table of results. I want to see while it's running how it's doing. Yeah?
Mhm.
So here are two things we have to change. The update frequency is like glasses, or it's the infinity. So
Mhm.
we would start the test, and if we stop it, we get numbers. I don't want
Mhm.
that. I want
Mhm.
numbers while it's running, so I can specify an update interval, for
Okay.
example, every second.
Mhm.
And then another results since start of test or last update. If I want results every second, new results here, what is done the last second, I choose last update. If you
Mhm.
want, for example, run the test for 30 minutes and you want a very even numbers, you go here with start of test. But I want the results of the last update frequency. So
Mhm. Okay.
now I do something very weird. I save the configuration. I tell you later why I'm doing this. And if you save the configuration in the same directory where the binary is, it's called IOmeter, yeah, um, then it will be loaded at the next start. And now I kill all the workers.
Mm. Okay.
And let me start this. Now it's preparing the drive. So we will look at the C drive. Here you
Mhm.
see we have our file. It started to create, and yeah, it's not showing. That's a problem with Explorer sometimes. So let me. It's creating data, but it's not showing it. But if you go there and go to the properties, we see we have already written 2.9
Okay.
gigabytes, and now it's there, and now it's updating for a bit. Yeah, weird, right? So now
Mhm.
it's not updating anymore, but it is creating the file. You see it here. Yeah. So it takes, let's say, a minute, uh,
Mhm.
and depending on how large you do your file. So if you forget the tip, if you forget to put a number here, so there would be the 0. It starts writing the file and it will stop writing the file if the disk is full. So in my example, it would generate a disk of 35 gigabytes. It takes a
Okay.
while. Yeah. So specify a number here, otherwise it will write it full. And there is sometimes an error with the software. It will write anyway a larger file. Let's see. So now we
Mhm.
are exactly at 10 million kilobytes, and we see the results here.
Mhm.
So we get results every second, and these are not bad for the benchmark we do, but they are also not great. If you heard about 100,000 IOPs in one VM, that's not
Mhm.
100,000, but we will get there. Yeah?
Mhm.
So now we see 5,000. What are the numbers? These are 5,000 IOs per second. Here we see the data that is moved. So we see that we read and write, 50% read, 50% write. We read and write 40 data, 40 megabytes. Yeah.
Mm-hmm.
So it's roughly 20 megabyte read, 20 megabyte write, if the test is
Mm-hmm.
doing right. Then we see the average latency. Over these 5,200 IOPS, we have an average latency of 0.2 milliseconds. That's good.
Mm-hmm.
It's really
Mm-hmm.
good. But not every IO is equal. So there are some IOs that take longer, and here is the longest in this period. So out of these roughly 5,000 IOPS, there's one, the longest, that has 4.6 milliseconds,
Mm-hmm.
1.0. Yeah, you see the CPU utilization. So let me add something that I like to do. PowerShell. Let me. That's wrong. Let me just get an administrative PowerShell. You know what I do. Disk perf minus
Mm-hmm.
yes. So you know what that does. I assume. So if we open the task manager,
Yep.
we can also get the disk counters here. Yeah,
Mm-hmm.
you have the same under Windows client. You can do the same with server when you
Mm-hmm.
enable them, and I did that. And you see here also the 0.2 milliseconds latency, average response time. It's the
Mm-hmm.
same as here, right? Because some people said this is an old tool, it's not accurate, but Windows server sings the same. And we can also
Yep.
watch the numbers in Windows Admin Center.
And you could
So,
even see that the read-write, distribution is equal as you specified the load pattern, right?
yeah.
Okay.
So we go to Windows Admin Center a bit later. So now we see that
Mm-hmm.
5,000. Okay, we can increase the update sequence so that we see the numbers for a bit. Let's say 5 seconds. Yeah,
Mm-hmm.
but this is still the IOs per second. So IOPS
Mm-hmm.
is IO operations per second. Now this is all per second. You see it here. But now the update is all every 5 seconds. Okay. So now let's tweak it. Yeah,
Mm-hmm.
because what we did is one outstanding IO with
Yep.
one worker.
Mm-hmm.
Yeah. So uh, what does it mean? So the application is allowed to write one IO against the storage system. So one read, and then it has to wait that the read is giving the data back. And
Mm-hmm.
then it can do a write. So it writes one block, one sector, and it has to wait unless the storage system is saying, okay, acknowledgement, I wrote the data for you. So this is very very brave, not brave, very liberate. So it doesn't do a lot of I/O. The storage
Yep.
system can do more I/O, but here is no parallelism. It's only one worker doing one I/O at a time. So
Yeah,
when we
usually
increase,
an application is not so polite and waits until, it,
yeah,
it
and
you know, just fills a
yeah,
queue or just,
some are, yeah. So let's do 10. I usually
Mm-hmm.
go with 10
Mm-hmm.
outstanding IOs, and the numbers will change after 5 seconds, and we give it another 5 seconds, and then we should have consistent numbers. So now we get around 20,000 IOPS. We
Mm-hmm.
move 165 megabyte of full random data. We have an average latency of zero point 0.5 milliseconds. The latency increased because we say the storage system read, write, read, write, read, write, read, write, read, write. And then if the first write or read comes back, we can do another one. Yeah? So we
Mm-hmm.
fill up the queue. And of course, the average latency per IO is getting longer because the queue is filled up and the storage system has to do something. So,
Mm-hmm.
but it's still very nice, and we get 20,000. So we can now tweak it more. We can add, play around with the outstanding IOs, but then our latency is going up and we don't get much more IOPS, maybe 30,000 or so on.
Mm-hmm.
We sacrifice our latency. Yeah. So
Mm-hmm.
now let's do something else. Let's load the configuration. And I've never done that. So here we have our 8 workers, but we have to go here. It's still the 1 here. So I add the 0. And now let's do the test with 8 workers because we don't want to
Uh,
extend this video too long, right?
You may want to change not only worker 8 with the 10.
Yeah, it's completely correct. So if I only change this, I would know it now with the number I see because there was something wrong, but you should change every worker to 10, right? And if we do it on the host, the numbers, now it's set for every worker. Okay, so do this again. And you see here, we have IO, we don't have IO, we have IO. Nice. So now you see we have 70,000 IOPs. We are moving half a gigabyte of full random data per second. And you see here we have 1.1 millisecond of average latency. Yeah, this is, of course, 50% read, 50% write. Yeah. And here's something happening. That is, if you get errors, when the CPU workload, the CPU load is not too high, there's something wrong with the test file. So you see here, we have 35,000 errors. Yeah, that's not good. So, but we don't have much CPU. So if you got into the 70, 80% of CPU usage, you usually get errors, but not at 30%. And I had the same weird thing at a customer just recently. So what you do here, you save your test. Yes. You close the application. You kill the test file.
Okay, get it.
You start it again, and usually it should be fine. Otherwise, if you get so many errors, you maybe have a problem with your um, virtual disk. So here now you see, if I have it in my directory, it will load it again, and we don't have a test file, so it will prepare the drives again. So what should you expect, and what do I do? Independent on how many nodes you have. For example, if you have a 2-node Azure Stack HCI cluster with some HDDs and some SSDs as caching device, you should see 50,000 8K IOPS, full random, 50-50, so 50% read, 50% write, unless you have maybe a very small installation. So there are some boxes out there. They look like a Synology or QNAP device. They are maybe not so fast. They maybe give you 30,000, but 50,000 usually with servers you should see. If you go up all NVMe, a lot of NVMEs, a lot of hosts, you see maybe you should see over 100,000 with decent latencies. Yeah? Here we didn't have decent latencies. It was already over 1.4 milliseconds. I mean, with decent, roughly around a millisecond. That's my sweet spot. Yeah. With an installation I was last week doing with 6 nodes, all NVMe, we had 180,000 IOPS with really nice latencies without error. So, and you told me you got even an installation with 200 or 220,000, right? So, you see how much I/O one VM can do on this cluster. It's only one VM running. Yeah, to be fair, it's not 50 VMs running, but if the application does so much pressure on the storage system that we have, it can get the I/O. Yeah. Usually the application doesn't put so much pressure on the storage system, but the storage system can deliver this I/O. If the application doesn't request it, it's not the fault of the storage system. The storage system has enough performance. So now we see 55. That's also not great, but and here something is maybe not so good with this design, but we will remember the numbers. Yeah, we should see more. We have a 3-way mirror. I don't know what's wrong. We have an 8K, so let's see what's here. Just check it, not edit, copy. Stupid. Edit. So we have 8K, 100% random, 50-50. Everything is fine. Maybe something with my volume. But you see, we have 70,000. So it's still in the numbers I told you that you should receive. So if I do it again, We have roughly 50,000. That's disappointing, and 1.4 milliseconds. Yeah. We will see how the Linux test is doing.
Mhm.
Yeah. Do you have questions, my friend?
No, I think it isn't a complex or difficult setup, right? The tool is a little bit, love demanding, as I would say, but I think it is something really that should be done. Otherwise, you don't know which kind of performance your virtual machines will get. I think
Yeah,
it's a good thing to demonstrate if the cluster is sort of in working in expected ranges, because I have found issues using that tool, right? Where I
hmm
saw IOPs going up and then down and then staying there for a couple of seconds at zero, right? Because otherwise you would not see that in production, and you don't want to find that out when it's in production, right? So you want to,
I'm completely
after
with you.
the after the
Yeah,
installation, that's
yeah.
something. Oh, that's a
So
nice view. Yeah, yeah.
yeah, I would investigate my cluster. To be honest, between our videos, I had to turn it down and create a stretched cluster because I did a stretched cluster presentation somewhere, and now I set it up last weekend, and maybe I missed something. So here is something not okay with this cluster.
Hmm.
This cluster should do 120, 130,000 IOPS with better latency. So something
Hmm.
is wrong here. I have to investigate. But this is why we do the test.
Hmm.
If you, like me, have done this test at least 1,000 times, maybe much, much more, you know which numbers are okay and not for which design. And this is a 4-node, all
Yeah.
NVMe cluster with very high storage bandwidth between the nodes. You saw that in the live migration test, right? This cluster should do better. And now it's time to investigate what's wrong.
Hmm.
Yeah, this is something that we get out of the cluster. But I just were while you were talking, I just switched to Windows Admin Center to show the volume, and we are in the volume collect where
Hmm.
this benchmark lives. Yeah, and we see here, and this I love. We see our 27,000 read and write IOPS. So
Hmm.
IOmeter is exactly doing on the volume what we told him. It's here very smooth at our 10
Hmm.
seconds. And you
Hmm.
see here we have a read latency in the volume of 116
Hmm.
microsecond and 160 microsecond. That's also very nice. Yeah, we have a
Hmm.
little bit more latency in the VM because it's another layer, but on the volume we have really nice latencies. And here you see the throughput, 212 megabyte, 212. That's also the 50/50. So
Hmm.
you see here in Windows Admin Center, and this really I love about it, you see the numbers. Yeah?
Hmm.
We could even dive into the drives, what the drives are doing, but here you see the numbers of the volume and even over days, weeks, months, and years. Okay, so enough for that, and I will investigate, and we will do another test with Linux and maybe show better numbers with IOmeter if I find the problem.
Okay, see you next time.
See you.